Hey guys, so here's another video in the series of videos here. I'm going to try and explain to you guys how ionization works. All right. So here we have three elements, three atoms, and we have their Bohr models. The Bohr models are blank. We're going to fill them in here in just a minute. And we're going to try and figure out why some atoms become ions and why they want to ionize. All right. And then once we do that, we're going to get into what kind of atoms or ions they form, excuse me. Okay, so we're going to start off with a couple. We're going to do a Bohr model just to refresh our memory. Okay, so we're going to start off with neon. Okay, neon is in the second energy level. So because it's in the second energy level, it has two rings. Okay, neon has an atomic number of 10, right? And because it has an atomic number of 10, that means that it has 10 protons. So we're going to go in there and we're going to put our 10 protons. 2, 3, 4, 5, 6, 7, 8, 9, 10. And if it has 10 protons, that means that it has 10 electrons. So we're going to go ahead and add those electrons now. Okay. In the first energy level, we have capacity for 2 electrons. And in the second energy level, we have 8 electrons. And we figured this out by counting the number of steps in the second period until we get to neon. So if you start at the beginning of the period and you count all the way to neon, you should get a total of 8 steps. 8 electrons plus 2 electrons gives me the atomic number 10. Okay, so what we notice about neon is neon has a full valence shell, right? If you can see this here, right? This outer shell right here, which is called the valence shell, right? Or where the valence electrons live, we see that it's full. It's full of electrons, right? It takes 8 electrons to fill up a shell, generally speaking, okay? And neon has 8 electrons. So it's got a full inner shell and a full outer shell, right? This is the reason that this is called a noble gas, right? Noble gas because it has a full valence shell, right? And is generally considered to be pretty inert. It's unreactive. All right. Now, I want you to remember what a full shell looks like. So when we do the other atoms, we can kind of do a small comparison, compare and contrast, okay? Okay, so let's take a look at fluorine. Okay, fluorine has an atomic number of 9. So that means that if I was to zoom in to the nucleus here, right, of fluorine, I would see that it has 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 protons. Okay. All right. So looking at the electrons, if it has 9 protons, it must have 9 electrons. So let's go ahead and take a look. 1, 2 in the first energy level. Remember, fluorine is in the second period, so we have 2 rings. And if you count across the periodic table, you're going to see that it's going to take 7 electrons to get to fluorine. So we're going to go ahead and put in those 7 electrons. Okay. If you notice, 7 on the valence shell plus the 2 on the inner shell, right? That gives you a total of 9 electrons. 9 electrons. Okay. Let's do the same thing for magnesium. Magnesium exists in the outermost shell. So magnesium exists in the third energy level, right? In the third energy level, so we get 3 rings. If you were to zoom into the nucleus, you would see that there are 12 protons. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 protons. And if we were to go ahead and do the electrons on this, we should also have 12 electrons. In the innermost, we have 2 because the first energy level, the first row of the periodic table only has 2 elements. So we can only fit 2 electrons. Second energy level is completely full because it's in the third energy level, right? So this one should have full electrons, which is 8. All right. And then to get to magnesium, on the outermost shell, we should have 2 electrons. 2 electrons. So they are, there they are. There they are, right? Let me go ahead and zoom out here a little bit. Okay, so now we have the Bohr models for all 3 of our elements, okay? Let's take a look at our shells, right? Now, what we notice is that neon has a full valence shell, right? But fluorine and magnesium do not have a full valence shell. Now, when I say valence shell, I want to make sure that we're all on the same page. The valence shell is the outermost energy level, the outermost. The outermost shell is the valence shell. So I want to make sure that we're all using the same nomenclature, okay? There we go, valence shell. So the electrons that exist in the valence shell, those are your valence electrons. Now, let's take a look at and compare neon to fluorine. So neon has 8 electrons, right? And it has a full shell. Now, why this is important is this, okay? I want you guys to take a look at this. Okay. Fluorine has 9 protons. We said that already, right? 9 protons. And it has 9 electrons. Electrons carry with it a negative charge. Okay. If I have 9 protons and 9 electrons, then I have 1 negative for every positive, which means I end up with a 0 charge. I'm neutral. 0 charge. Okay. Let's take a look at magnesium. Magnesium has 12 protons, which carry a positive charge, and has 12 electrons, which carry with it a negative charge. And if I take 12 minus 12, I should end up at 0 charge. Okay. Neon is no different. Neon also has protons. In this case, it has 10 protons. Okay, it has 10 electrons. And if I have 1 negative for every 1 positive, then I should be, here's a big word, electrostatically neutral. Electrostatically neutral. That means I don't carry a charge. Now, atoms in their ground state, right? In their ground state, carry no charge. They're neutral. They're neutral. Now, in the quest for atoms to be like noble gases, right? What they're going to do is they're going to change the number of electrons, okay? And here's how you determine whether or not an atom is either going to pick up electrons or to drop them off, right? So you ask yourself this question right here, okay? Based on where you are with your Bohr model and in your valence shell, would it be easier for fluorine to pick up 1 electron, right, to have a full shell like neon, or would it be easier to drop 7 electrons, right, to have a full inner shell, right? So those are the 2 questions of the day, right? Those are the things that we need to ask ourselves. So is fluorine going to pick up 1 electron or drop 7 electrons, right? Just in the terms of energy, right? Which seems to be easier? To pick up that 1 missing electron to have a full outer shell, or to get rid of all 7 valence electrons to have a full inner shell, right? So in terms of energy, what's going to be easier? It's going to be easier to pick up just that one electron. So that's what fluorine's going to do. It's going to go out and it's going to find that one electron, right, to have a full outer shell. So I'm going to mark that as an X so you can see that that's the one that it picked up, right? So let's label that here as a picked up electron. Picked up electron, okay? Now, what does that mean, right? If you pick up an electron, well, here's what it means, right? The process of picking up an electron has a name. We call that reduction. Let's go here. We call that reduction. Now I know what you're thinking. Mister, how can it be called reduction if you're picking up electrons? Well, I'm going to explain to you that in just a minute. Let's take a look at fluorine now that it's picked up this extra electron. What happens? Well, fluorine still has 9 protons. We can't change the number of protons because if we change the number of protons, we change the element. So it has 9 protons. But now, instead of having 9 electrons, right, it actually has 10 electrons. Because it picked up that extra one, right? Let me show you. Look, here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because it picked up that extra electron, it now has a total of 10 electrons. So what used to carry a 0 charge, well, now it has 1 extra electron. So what happens to that charge? Well, what happens is if you have 9 protons and 10 electrons, you end up with a -1 charge. -1 charge, because now you have more electrons or more negative particles than positive particles. So what happened is fluorine is now an ion. An ion is simply an atom that carries a charge. So how do you represent the fluorine ion? Well, it's simple. You take the chemical symbol for fluorine. Let me make this a little bit bigger here. Take the chemical symbol for fluorine, and then you write its charge. In this case, fluorine is a -1. -1. Okay? Because this is now a negative ion, right? It is called an anion. We call that a negative ion. It's called an anion. Okay? This symbol here represents the oxidation state. The oxidation state is just a fancy way of saying what charge does the ion carry? Charge, right? So fluorine ionizes, right? Ionizes to become a -1 ion. Called an anion. Okay? An anion. All right. Now, does magnesium behave the same way as fluorine? Well, let's take a look. Remember, the goal is this. This is our goal. We want to have either a full outer shell or a full inner shell. Okay? Fluorine thought it'd be easier to pick up 1 electron to be like neon and have a full outer shell. Magnesium, though, is a little bit different. So let's ask ourselves the same question, right? Would it be easier for neon to pick up six more electrons to have a full outer shell, or drop just 2 electrons to have a full inner shell. Remember, magnesium has two shells on the inside that are already full. This guy's full, this guy's full, right? So having a full shell is good whether you do it on the outer shell or you do it on the inner shell. It just depends on which one's going to be easier for you in terms of energy. So if I'm looking at magnesium, right, that has just two valence electrons, 1, 2, would it be easier to go out and try and find the 6 missing electrons to fill up the outer shell? Or would it be easier just to drop the 2 extra electrons it has on that shell and then have 2 full inner shells? Well, in this case, it's going to be easier just to drop those 2 electrons, right? It's going to be easier to just get rid of those guys. When we drop electrons, okay, when we drop electrons, that process is called oxidation. Oxidation. Okay? Now, what's going on when something oxidizes? Well, we already figured out that what we're going to do is we're going to get rid of these 2 electrons. So let's go in there and let's get rid of these 2 electrons. I'm going to color them in here. Okay. Boom, gone. Okay. So those 2 electrons have now been either donated, to something else, and they're gone. Okay. So what's going on when something oxidizes? Well, let's do the math, right? Magnesium still has 12 protons. Remember, we cannot change the number of protons, right? But now, instead of having 12 electrons, remember, it got rid of 2 electrons. So now instead of 12, now it only has 10 electrons, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The 2 that it had on the outside are no longer there. So it only has 10 electrons. Now, if we have 10 electrons and 12 protons, 12 minus 10, I end up with a +2 charge. I end up with a net positive charge, right? So what's happened to magnesium? Well, what's happened to magnesium is now an ion. And how do you represent an ion? Well, you do the chemical symbol, and then you write down the charge of the ion. In this case, it's going to be a 2+ ion, a 2+ ion, right? You can write that as a 2+ ion, or you can write that as a +2 ion. Either way, it's the same, okay? So when we're looking at a symbol like this symbol represents that it's now an ion. Okay, now because magnesium is forming a positive ion, we call this guy a cation. And that's a positive ion. All right. This symbol here, the charge itself, just like on the other one, represents the oxidation state. And remember, the oxidation state is just a fancy way of saying charge, right? So the oxidation state of the magnesium 2+ ion is +2, right? So magnesium has now become an ion or ionized to form a +2 ion. Okay, and atoms do this, right, to try and achieve status just like noble gases, right? Just like noble gases. So when you're looking at a noble gas like neon, right, and everybody's trying to be a noble gas like neon, does neon find itself in a position to want to either pick up or drop electrons? No, no. because it's already full. So elements like neon does not ionize. And when I say does not ionize, that's just a fancy way of saying does not form ions, right? And what are ions? Ions are atoms with a charge. Ions are atoms with a charge, and they get those charges by either picking up or dropping off electrons, right? If they don't do either, they don't ionize, okay? If you're a negative ion, you're called an anion. If you're a positive ion, you're called a cation, okay? And this, guys, is ionization in a nutshell. You determine whether or not you become a positive or a negative ion depending on whether you pick up electrons or drop them off. And you make that determination based on whether or not it's easier to fill up the outer shell or empty the outer shell, okay? All right, guys, that's pretty much it for today. Let me go ahead and zoom it out so you guys can take a full look at the screen. Feel free to screenshot this if you like. If you have any questions, please let me know.